You guys just give me a shout out. Hi, Cameron. Did you have a good spring break? Hi, Sophia. All right, so we're going to do 10.3 today. You guys are going to have to do lab 9 this week. And that's pretty much it for this week. Next week's going to be the busy week, I think. So next week is going to be 10.4, 10.5. We'll review for the study guide. You guys will have to do lab 10, which of course if you want to do lab 10 this week, that's fine too. And then remember the final is 2 parts. So it's part 1 and part 2. And then I have your homework being due Thursday the 30th. And you also have to do your surveys. So there are end of the year surveys and they're bonus points. So you definitely want to make sure that you get in the surveys done. But I don't think the surveys are open yet because I think it's still a little bit too early. Because I think WVU's last day is like May 4 or May 5, somewhere in there. So I would probably start looking for the surveys, probably even on the 27th, to look to do the surveys. I mean, it's bonus. If you do it, you get the bonus. If you don't do it, you get nothing. So make sure that you do the bonus. Yeah, I hear you with the spring break being kind of boring, not being able to go anywhere. It really didn't even feel like spring break. It all felt the same, didn't it? All right, well, let's go ahead and get started. So we've got 10.3 here. And this is going to be talking about graphing complex numbers now. Okay, so a complex number, which you should have learned this last year, is just an x plus y and I. So I is for the imaginary number. So this could be any number here, and the y is any number. Y can't be 0 though, because then you would just have a regular number and it's not complex anymore. Okay, tentative sketch. This would be your y. So your y-axis is like the imaginary axis. And then the x-axis is what we call the real axis. So you basically would plot your x, plot your y, and then this z dot, which is your point, is your x plus yi. All right, so the next one, this is just plotting ones that actually have numbers on it real quick. So we're going to plot z equals the square root of 3 minus I. So the first thing you're going to need to know is what is the square root of 3 ballpark as a number. So I would just type that in. Square root 3 is about 1.7. So we're going to just ballpark that. So 1.7 would be round about there. And then this would be -1. So we'll go there and then we'll go down for the -1. So that's the z, square root 3 minus 1i. So there's really not much to this, so that's kind of good. Zoom in maybe a little bit more here so you can see this better. All right, now this next one is definitely promise on the final. We'll probably even put that on the index card because I think it's that important. So the magnitude, they're going to call it magnitude. This is just a definition. It's also known as modulus. but on the final, they're going to call it magnitude. So its magnitude's the word that you're going to want to know. All right. So the magnitude of z is notated, and it looks like it's the absolute value of z. I mean, that's what the notation looks like, but you would read this as the magnitude of z. Okay, so if you see anything that looks like absolute value bar, that's the magnitude. All right, so this is defined as the distance from the origin to the point x comma y is, and then this is what it is. So the magnitude of z is the square root of x squared plus y squared. And you will have to memorize that formula. That's definitely on the final. And it's really easy as long as you have the definition memorized. It's not hard. All right, so the next one here, and I would put this on your index card. If you still have your index card, I would definitely add that to the index card. Magnitude, and then I would put it like that, equals the square root x squared plus y squared. So put that on your index card also. Okay, this next one is also a definition before we actually get to the problems. So writing complex numbers in polar form. All right, so for this to work, you have to have that r is greater than or equal to 0, and your theta is between 0 and 2 pi. So normally when we would write a complex number, we would have z equals x plus yi. Okay, and what we're going to do is we're just substituting that x. Remember, x was like a cos of theta, so x is r cos of theta. That came from the last section. And y is r sine of theta. Okay, and then if you look on both sides, notice the r's in both places, so we're going to factor out the r. So this would be r cos of theta plus I sine of theta. You can put the I in behind theta if you want. Just note that the I and the theta are not together. All right, so what we're going to do is we're going to take that problem that we had done right here, and we're going to write that complex number in polar form. And the r is called the argument of z. So just as a side note, r is the argument of z. So x would be your square root of 3. Y would be equals the square root. This is x squared plus y squared. So x squared would be the square root of 3. So this is the square root of 3 squared plus -1 squared. Okay, this is going to cancel out with that. So basically we're looking at 3 plus 1, so that would be the square root of 4, and the square root of 4 is 2. So we know that r is going to be 2, and then we're going to need to plug in for sine of theta and stuff. We're going to need to figure out what theta is. Okay. Now on the flip side, the cos of theta is x over r. So x was the square root of 3, r is 2. So we need to figure out what theta is. So if you think, we know that we're in quadrant 3 just from the graph up above. So I know I'm down here. So here's my theta. And that says this is the square root of 3. So you should ask yourself, what does theta have to be that's diagonal? It's going to be 11 pi over 6. Alright, so our official answer, z would be equal to, so our r is 2, cos, and our theta is 11 pi over 6, plus I sine 11 pi over 6. And this would be your answer. Okay, only work, and a lot of times they're not going to come out that nice and pretty. So this is what you're going to do for, this is actually I think number 21 in your book. Most of the times they're not going to be. And they want you to plot it in the complex plane and write it in polar form. So the first thing we're going to do is plot this. So this would be at -2. So our x is -2, and then we're going to go up 3 because that's positive. So I'll come over to up 3, put my dot. So there would be my graph right there. So you can go ahead and connect that there. Then we need to find our r. So -2 squared would be 9. 4 plus 9 would be 13. So this would be the square root of 13. Alright, so then what you're going to want to do, since this isn't going to come out pretty, square root of 13 is not one of our special cases, you're going to want to use the tan. So this is what you do for probably 90% of them, because most of them aren't going to come out nice. So the tan of theta is y over x, -2. And we want to use tan because that's the only one that gives us the exact values on here. So I want to find theta, so I want to do the tan inverse of 3 over -2. That will give me theta. 3 over negative 2. All right. So that gives me, so you might want to put a note on here that you want your calculator in degrees. So this is negative 56.3 degrees. Okay, so this right here is actually the reference angle. So if you look over here, what we're saying is between here and here would be your negative 56. So this would be your 56.3 degrees. All right, but what we really want is we want to know the actual measurement of this angle, which I know that this is an obtuse angle. So you have to go with your corners here. So if I'm in quadrant 2, then I need to find the actual thing and not the reference angle. So this would be your reference angle. Quadrant you're in. Okay, so we're going to do 180 minus 56.3, and that gives me 123.7 degrees. So that would be the real one that we want. All right, so our answer, so our R is the square root of 13, and then we're going to do the cos 127.3 degrees, or no, I got that way backwards. Got the 3 and the 7 backwards. Being a little dyslexic there. 123.7. Okay. Plus I sine 123.7 degrees. Okay, so some things we need to note. Depending on where this reference angle is at, what quadrant it's on, depends on what you're going to do in this step right here. So if it's in quadrant 2, you're going to do 180 minus the number that they give you. If it's in quadrant 1, you don't have to do anything. All right, if that reference angle, and that's why you need to plot them first. So if the reference angle is in quadrant 3, okay, so if that reference angle happens to be in quadrant 3, then you want to do 180 plus the number you got. And that number is that reference angle that you got from doing your tan inverse, okay? That's what you're going to do if it's in quadrant 3 down here when you went and plot it. All right, now if it was over here in quadrant 4, then you're going to do 360 minus the number. Okay, and that's what I mean for this blue step right here. That's what you would do for these, depending on what quadrants you're in. If it's in quadrant 1, you don't need to do anything. Just stick with the number they give it to you. Okay, the next one that we're going to do is 26. So this is going to help you for 23 to 32. Okay, so it says plot the point and write the equation in rectangular form. So basically they're giving it to you backwards. So this one is number 26. So this is 2 cos 5 pi over 6 plus I sine 5 pi over 6. All right, so first thing that you're going to want to do is you want to graph this. So when you're graphing this, remember this one would have to be 6 pi over 6. So 5 pi over 6 has to be up here. So this would be your 5 pi over 6. Since it's a 6 on the bottom, I know that this has to be 30 degrees. You know, your hypotenuse is always 2. 1 has to be diagonal from the 30. And since this is in the negative side, this would be negative square root of 3. All right, so now what I want to do is I want to do 2 times. Now, what is the cos of 5 pi over 6? So you're going to look at your triangle and figure out what that is. That would be negative square root 3 over 2 plus, then look at your triangle and figure out what's the sine of 5 pi over 6. Well, that's going to be 1/2, and then you still have that I in there. All right, then you want to distributive property here with your 2 on the outside. So when I go and distribute the property with the 2, it basically knocks all those 2's out. So this 2 would cancel with that, and that 2 would cancel with that one. So our official answer here, negative square root 3 plus I. Okay, now we got some more definitions. This is products and quotients of complex numbers. Okay, so the first thing we have to assume that they give you a Z1, and that's R1 cos of theta 1 plus I sine theta 1. So that's the first one. So you can only multiply and divide 2 numbers, so they have to give you 2 of these things. So then the second one we will call Z2, Z sub 2. So that would be R2 cos theta 2 plus I sine theta 2. So this is kind of like your first number, and that would be your second number. So then now that we have 2 numbers, we'll be able to multiply, and then we'll be able to divide. Okay, so here's our first formula. Z1 times Z2. That's a Z. That's a horrible Z, but that's a Z. All right, so what you want to do is you want to times the 2 R's together. So that would be R1, R2. So we're timesing. Add them together. So theta 1 plus theta 2 plus, and then we'll have I sine, and the same thing. You're going to add them together for the thetas. So theta 1 plus theta 2. And I feel like that kind of makes sense that you need to add these thetas together, because the rule with exponents, when you multiply exponents together, you really add them together. So I kind of think of that, and it helps me remember which ones to add. And then, of course, when we go to do the dividing, those ones will be minusing. Okay? And you're going to take the first one over the second one. So R1 divided by R2. And then you're going to times cos, And try to think of these theta things as being like your exponents. So if I'm dividing exponents, you're really subtracting them. So this is going to be theta 1 minus theta 2 plus I sine theta 1 minus theta 2. All right, we good so far? All right, so we are going to do number 35. So this is what you're going to do for 33 to 40. I'm going to actually write it on the other paper. Okay. So number 35. And like I said, this is what you're going to do for number 33 to 40. And this section's really not too bad, I don't feel. I feel like this isn't. Sine 130 degrees. And then they call Z2, they're going to call that as W, which I find that easier. So this is 4 cos of 270 degrees plus I sine 270 degrees. All right, so the first thing they want you to do is times these. So Z times W, so you want to times the numbers in the front first. So we'll write it down the first time and then we'll go through and actually times them. So 3 times 4, and then you'll have your cos. And since you're timesing, think of these as your exponents. You're going to add these together. So this is 130 plus 270 degrees. Plus I sine, and then you're going to add them again. 130 plus 270 degrees. All right, so ZW, 3 times 4 is 12. Cos, 130 plus 270 would be a 400. Plus I sine 400 degrees. Okay, now the only problem with this is this number right here, the 400 degrees, it's too far down on the wavelength. It needs to be between 0 and 360. So this number, and they should be the same, but those two numbers must be between 0 and 360 degrees. So that's too high. So basically what we're saying is we're basically 1 revolution too far over on the circle grid. So to remedy that, and I'll write it down in your notes just so that you have one problem written down. So to remedy that it's too far down, you're going to take the number they give you if it's too high and just subtract off a 360 degrees off of it. That's how you're going to solve that problem. So that's going to give you the wavelength closer to 400 minus 360 would be a 40. So this is cos of 40 plus I sine of 40. Okay? And that's your answer for the first one. Of course, you can do a lot of this math in your head. All right, then we have to do z divided by w. So what you're going to do is you're going to take your two numbers, whatever one's on the top, that's the one that goes on the top. So this is going to be 3/4 cos. And then what you're going to do is you're going to take these two numbers and we're going to subtract them. So 130 minus 270 plus I sine 130 minus 270 again. Okay, we're going to leave that as the fraction. So that's going to stay as 3/4 cos, and 130 minus 270 would be a negative 140 degrees. Okay, now again, because it's negative, it's not between 0 and 360. So to remedy this one, what you want to do is you're going to take the 360 and put it in the front so we can get a positive number. So 360 minus 140, that's going to give us a positive answer. So we'll do 360 minus 140. So it kind of just depends on which end of the wavelength you are. If you got negative, do 360 minus. If it's too high, do that number minus 360. Okay, so our answer here is 3/4 cos. 360 minus 140 would be a 220. Plus I sine of 220 degrees. And that would be your answer for that one. Okay, now I'm going to butcher this guy's name, but this is a theorem. The Moivre's theorem? I can't pronounce these words. I don't know. Okay, just do the best you can with pronouncing it. All right, so this one's going to deal with exponent type things. So this is if z equals r cos theta plus I sine of theta is a complex number, then you have z to the nth power is equal to r to the nth power times the cos of n theta plus I sine, that's a horrible I, of n theta, where n is greater than or equal to 1. Okay, so that's a theorem. Okay, so we're going to do number 45. So this is what you will do for 41 to 52. You're going to use this guy's theorem for that. And we're going to do actually number 45. So they want you to write the expression in the standard form a plus bi. All right, so we have the square root of 3 times the cos of 10. I think that's 10 degrees. 10 degrees plus I sine 10 degrees all to the 6th exponent. Okay. So what we're going to do is we're going to use this formula here. So our n is going to be 6 because that's the exponent. Okay, so n is the exponent. So this right here, that's your n. All right, so we're going to have z to the 6th is equal to r, which is the square root of 3. So this is the square root of 3 to the 6th power cos, and we're going to do 6 times 10 plus I sine of 6 times 10. All right, so for this thing here, I would type that in a calculator and let that give you a nice answer. Okay. So we have this, I would probably start with parentheses. So the square root of 3 to the 6th power. Okay, so that comes out nice and pretty as 27, so that's good. All right, so this is 27 cos 6 times 10, that's easy, that's 60, plus I sine of 60. And this is 27 times that quantity. So what we're going to want to do is we want to find 60 degrees and figure out what the cos of 60 is and the sine of 60 is. Okay, so we have the 60 there. I know the square root 3 has to go diagonal from the 6. Hypotenuse is always 2. 1's diagonal from the 30. So this is 27. Cos is going to have to be 1/2. Plus I, and the sine of 60 is square root 3 over 2. All right, and then the next thing we want to do is distribute that 27. So this is going to be 27 over 2 plus 27 square root 3 over 2 times I. I guess you could put the I in the front. It doesn't really matter. I'm sorry about that dinging on my phone. Okay, and that's your answer for that. Okay, we're almost done. We got one more definition and problem and then we'll be done. All right, everybody get that on there? Okay, last one here, finding complex roots. Okay, so we're going to let W equal R cos of theta, and then this is a 0 down here as a subtitle. Okay. Plus I sine theta naught. So those just mean that this is just your original theta. Okay, so this is the original problem that they started out with, okay? All right, so that's going to be a complex number. And let n be greater than 2 is an integer. Greater than or equal to 2 be an integer. Okay, give you guys a second to write that all down so we can see it. All right, so this says if W is not equal to 0, then there are n distinct complex roots. Of W given by, okay, I'll let you write that down real quick before I tell you what this equation is. All right, so Z sub K, and it's a sub K because they're going to have to tell you in the problem how many of these you're going to have to do. Okay, so this could be a first root, a second root, the third one. It just depends on how many distinct ones there are, and they'll specify in the wording. Okay, so this is the nth cube root type thing. So this is the nth root of R times cos of theta naught divided by n plus 2k pi divided by n. Give me a second to write that down, then I'll give you the rest of it. Okay, plus I sine, and then it's just going to replicate this. It's going to be the exact same thing as that. So theta naught divided by n plus 2k pi divided by n. Wow, that's a horrible looking n. Okay, and n can be 0, 1, 2, 3. It just depends on what they give you. When we do the problem, I think it'll make more sense. 0, 1, 2, dot, 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 n minus 1. So they're saying you're going to have to unfortunately do this multiple times. And this is what we're going to do for 53 to 60. And we're going to actually do number 56. Okay, so it says the complex cube roots of, and then that gives you the problem. So this is really important that you read the words they give you. So the complex cube roots of -8 minus 8i. That's the problem. The directions say find all the complex roots. Leave your answer in polar form with the argument in degrees. Okay, so you're going to have to read this word right here. This is the important part. How many roots did they tell you in there? It could say square root, it could say cube root, some of them say fourth root or fifth root. That's how many times you're going to have to write this thing out. So cube root means 3 answers. If that had said the 4th root, then you're going to have to do 4 answers. So you'll have to do this thing 4 times. You'll see when we get there. So this one is cubed, so we're going to have to do this 3 times. So the first thing you want to do is convert to rectangular coordinates. So that's the first step that we're going to want to do. Alright, so I would probably plot this just so you kind of know what quadrant you're going to be in too. So -8, -8i, so -8 would be over here. And then -8 going down. Okay, so that would be the junction of that. So I know I'm in quadrant 3. So x is -8, y is -8. You got to find that r. So this is going to be -8 squared plus -8 squared. Okay, so that would be the square root of 64 plus 64. So that's the square root of 128. But this is really, since I want to break this down quickly, so this is 64 times 2. So I can take out the square root of 64 is 8. So this is 8 square root of 2. So that's our r. So that's the first thing that we need, because we need that r for this here. So this is going to be that r for that. And then I'm going to need to find my theta. So again, I would do the tan thing. So tan of theta is going to be -8 over 8 over -8. So that's -1. So what we want to do is theta is equal to the tan inverse of -1. All right, so we're going to type that in. Okay, second tan inverse -1. So that gives me -45. Okay, now the thing is I am not in quadrant 1. This is this quadrant here. So I need to figure out what that angle really is. So 45 is the reference angle from here to here. This is the 45. But what I really want is the entire angle from here down to there. So since I'm in this quadrant, I'm going to want to do a 180 plus my 45 to give me what I really want. So my theta is really going to be 180 plus the 45. So that's going to be 225. Okay, so what we're looking at, we're going to put this together now. So our W is going to be, and I'm going with the W as being this up here. So this is what I'm doing for my W. I'm going to just take what I got and put them together. So my R is 8 square root of 2. Okay, then I've got the cos. And my theta is 225 degrees. Plus I sine 225. All right, now we're going to do a general formula for K before we plug in the first three things. So since this is a cube root, I'm going to have to do n is 0, n is 1, and n is 2. But before you plug those in, it's easiest to get a generalized formula and then just plug everything in once you know that generalized formula. All right, so RZ sub K is going to equal. Now they tell you the n in the very beginning. If you don't go back and read the beginning, you're going to be sitting here wondering what in the world is n. Well, they tell you in the very beginning the cube root. So that's your n. So your n is going to be 3. Okay, if they said 4th root, then your n would be 4. 5th root, your n would be 5. So you're going to have to read to see what they give you for your n. So this is going to be the cube root. And our r is 8 square root of 2. So this is going to be very ugly looking. We'll fix it though. All right, and then we're going to do the cos. Our theta goes on the top, so I'm literally just using this formula up here. So our theta is 225 divided by, and our n is 3. Plus I sine 225. Wait a minute. I didn't follow the rest of the formula. I tried to jump the gun there. That's not gonna work. Okay. Yeah, I kind of need that 2k pi thing. All right, so this is going to be 360k divided by, and your n is 3. Okay, don't jump the gun. All right, so that's part is the cos part. Plus, now we can do the I sine. I sine, our theta is 225, 360. So this is 360k divided by 3. Start with is this over here, because that is just really, really nasty. Of 8. What I'm going to do is I'm going to take this cube root of the square root of 2. Okay, so this is now 2 completely separate things, kind of. All right, so the cube root of 8, I would do my tree for your 8. So that's 4 and 2, and I know 4 breaks down 2 and 2. This is a 3, so you need groups of 3. So the cube root of 8 is just plain old 2. It's just a, but it's 2. So what you want to do is, since I'm kind of timesing these square roots, you want to add your indexes there. So 3 times 2 would be 6. So this is 6 square root of 2. I can't talk right today. That's the 6th root of 2. Wow. Okay. So 3 times 2 is 6. So that's your index is 6. And then you got the root of 2. So this is going to be 2 6th root of 2. Yeah, I know, because sometimes my thing says the connection's poor, so I know that we're lagging. Yeah. By 3, I believe that comes out nice and pretty. That comes out as 75. All right, so this is the cos of 75 plus, and 360 divided by 3 better come out nice, 120k plus I sine of 75 plus 120k. Okay, so once you get this simplified from here, it's not so bad after all. So we're going to need to do 3 cases because this is the cube root. If it was a 4th root, you'd have 4 answers. So pray that they only give you the cube root on this. So we'll start with z sub 0. So basically, you're going to go through and put a 0 right there. So that's not terrible, I mean. So this is going to be 2 6th root of 2 cos 75 plus 120 times 2, or not 2, 0, plus I sine 75 plus 120 times 0. So your first answer, z sub 0, is 2 6th root of 2 cos of 75 plus, I forgot that extra parenthesis at the end, I think, I sine of 75. Okay, that's answer number 1. Like I said, since this is a cube root, you're going to have 3 answers. So that's answer 1. Answer 2 would be z sub 1. So instead of 0 there, you're going to plug in 1. So 2 6th root 2 cos of 75 plus 120 times 1, which is obviously just 120, plus I sine 75 plus 120 times 1. Okay, so here's your second answer. So z sub 1, and all you got to figure out is what's 75 plus 120. So this is 2 6th root of 2 cos, and 75 plus 120 would be 195, plus I sine 195. Okay, there's your second answer. So once you get the z sub k down, it goes a lot quicker. You're just plugging in your numbers for k. So there's the second answer. All right, last one. Z sub 2 is 2 6th root 2 cos of 75 plus 120 times 2, plus I sine 75 plus 120 times 2. So all we need to figure out is what's 120 times 2, and then add 75 to it. So that's 315. So cos of 315 plus I sine 315. And that's your last answer. Okay. All right, so do we have any questions? Who's still with me here? So it looks like only one of you guys is still watching. So which one of you is still watching? You want to give me a shout out? Or at least maybe my count's wrong, I don't know. Now I've got another one watching. Okay, Lucas is still here, so that's good. Now I showed that one more person showed up. Okay. I'm sorry if the lag was on there. It told me there was lag, but I don't know how to fix it. I don't know what I could do about that. Okay, and Sophia's still watching. Okay, the count number is really weird then. Because it says there's only 2 people watching, me and one other person. Well, obviously that's not right. So that's good. Okay, this section I don't think is really that bad. Just this last one, it has work to it, but this section's really not bad. Make sure you know magnitude. That's definitely on the final, for sure. Okay. Lab 10 you could also work on. And there should be more homework quizzes that you guys also need to do. So I have on here that you guys probably did homework quiz 7. I think there's 10 homework quizzes. So make sure you get 10 homework quizzes done. You probably won't have time to get them all done until next week. So we're going to say on the 30th that everything is due that day. Okay, so all of your quizzes need to be done, all your labs need to be done. Make sure you guys get a picture of your test 4 and send me a picture of test 4 because you should have that graded by now, I would think. It's been like 10-3 homework, 10. Alrighty. And Lucas, I don't know if we're still on for going back first, the governor, because we're right here. If I was him, I probably wouldn't even say anything until around the 23rd or 24th of next week, if I was the governor. Because I'd want to wait and play it out and see how this week... Our peak is supposed to be on the 16th. That's Thursday. And then everything's... We don't know. We really don't know. So, I don't know how the governor is going to play that safe or not. So, as of right now, I think until he says otherwise, I guess we are back on the 1st, May 1st, but I haven't really heard anything official. So, we'll just have to keep watching and waiting, but I don't really expect him to say anything till closer to the end of April. Because honestly, if he had to decide right now, he probably wouldn't know. But in a week, he might have a better idea. Alright, well, I'm going to go ahead and end this stream. And I'm sorry about the stream not being all that great. So I'll try to figure out how to get a better connection for next time's stream. Alright, you guys have a good day. How can I get a better stream? Oh, wow.